We have a test for correlation where we talk about the joint distribution of the two random variables x and y, which is a two-dimensional or a bivariate in the sense that we are dealing with pairs of data, normal distribution. Mathematically, it can be quite complex, but essentially it's the normal distribution of x and the normal distribution of y linked together by a parameter, which is called rho. Rho being the population correlation coefficient, so the population correspondent of the sample correlation coefficient R. Essentially, when we have one variable case, the probability that of our variable x being in between two values or above a value or below a value, it's an area problem. While in the two variable or bivariate case, the probability that x is doing something and y is doing something as a pair is generally a volume. And we have a theorem which basically drives the test for correlation. And the theorem is basically telling us that if the joint distribution for x and y is a bivariate normal, so we are under this assumption, the sample correlation coefficient R is a good estimate of the population correlation coefficient rho. And basically when rho is equal to 0, this is basically the no correlation case. Rho equal to 0 basically means there is no correlation. If and only if the two variables x and y are independent. So no correlation means independent random variables. And so the probability that x is less than equal to x and y is less than equal to y is equal to the product of the two probabilities by the multiplication rule for independent variables. Probability that x is less than or equal than x times probability that y is less than or equal than y. And then we have the two extreme case, when rho is equal to 1 and when rho is equal to minus 1. So rho equal 1 means perfect positive correlation. And in both cases, the relationship between y and x is a linear relationship. In fact, is expressed as the equation of a line. Y equal beta 0 plus beta 1 x. Beta 0 is the y-intercept and beta 1 is the slope of the line. Now, beta 0 and beta 1 are constant, but when rho is equal to 1, beta 1 is positive, so we call that a positive linear correlation. And when rho is equal to minus 1, so for a negative correlation, the coefficient beta 1 is going to be negative, creating a negative relationship. So having said that, we can go to the test of hypothesis. Then step 1 is the null and alternative hypothesis. Always assume that rho is equal to 0. So we always assume that there is no correlation. That's the sort of conservative hypothesis. Why should we think that there is a relationship between x and y? It needs to be proved. So we start thinking there is no relationship. And then we have three choices of alternative. Rho different from 0 is our two-tailed alternative. So basically, if we are wondering whether there is some sort of significant correlation. Rho less than 0 is we are testing for negative correlation. And rho greater than 0, we are testing for positive correlation. So you'll have to look at the wording of the question to decide which hypothesis to implement. So step 1, we have step 2. And step 2 is founded on the fact that if we assume that the null hypothesis is true, so assuming rho equals 0, then we are dealing with the sampling distribution of our estimator, which is R. And this sampling distribution will be normally distributed with a mean of 0 and a standard deviation or standard error of the mean, which is equal to the root of 1 minus r squared over n minus 2. And therefore our test statistic, which we'll call T star, we'll call it T because generally the size of the samples are small, and it will be equal to the sample correlation coefficient minus the population correlation coefficient, which is 0, and divided by the standard error, which is the root of 1 minus r squared over n minus 2. We generally like to recall this formula for test statistics, so simply if we do the division and flip the root as a result of doing the division, then your test statistic T star is going to be equal to R multiplied by the root of n minus 2 over 1 minus r squared, where r squared is the square of r. and the degrees of freedom are n minus 2, and the remainder is right there in the formula. So make sure you note is r minus 2. All the other steps are going to be the same as usual. We like now to do an example, and as example I'll take the data from before about the absences and the grades of the 7 students, and we are asking you to perform a test for negative correlation. We have a strong suspicion of negative correlation because when we calculated R, we found the value of minus 0.9442. So that was in the previous video clip. The number of pairs were 7. So correlation regression questions are very long. They go in steps. If we have a correlation data, we generally ask you to draw a scatter plot, and then depending on the visual impression of the scatter plot, they might ask you to find the correlation coefficient. They might ask you to test for correlation, and later on to find if R is significant, like in this case. Then they might ask you to find the equation of the regression line, and then to go into some sort of prediction. So generally a very broken down in steps question. So in here, using our R value that we found before, the null hypothesis will be as usual, assuming no correlation. The alternative hypothesis, I see a definite sense of direction because it says test for negative correlation. So it will be the rho is less than 0. And if it did say test for some sort of correlation, a significant correlation, it would have been two-tailed test. The statistic, I already wrote it down, is R equals the root of n minus 2 over 1 minus R squared. So when we go plug in, instead of R, we'll write negative 0.9442. I recommend you keep 4 decimals for R. N minus 2 is 7 minus 2, so it's 5. And as the denominator, you have 1 minus 0.9442 squared. And then if you perform the calculations, first calculate under the root, take the root. When I took the root, I found a value of 6.7889. And then I multiplied this value times the negative 0.9442. So we came up with a strong test statistic, minus 6.41. So this is going to be very likely a strong reject. Step 3 is the usual. Alpha is 5%. It's a left tail test on the t-tables. Therefore, the degrees of freedom are n minus 2 or 5. So I need to look on the table and to make my critical value negative. And I'm looking at 5% and 5. So the t-tables at 5 degrees of freedom will give you positive 2.015. But because it's a left tail test, we'll go by symmetry and say it's negative 2.015. And therefore, our test statistic will fall in the critical region. So we can say that since minus t star equals minus 6.41 is to the left of the critical value of minus 2.015. So being less than that, we can reject the null hypothesis. And so rejecting the null hypothesis is a positive statement. So we did find a negative correlation between the absences and grades of the students. So a clear-cut conclusion. So this is the test for correlation. Thanks for listening. Look for more.